Welcome dear learners to this video on chemistry. So this is our first video under chemistry. So in this video we're simply going to look at the kinetic theory of matter. Okay, so if you haven't yet subscribed to the YouTube channel, please click the subscribe button on the channel so you get subscribed. You can be following us as we post more videos on YouTube. So kinetic theory of matter. Okay, kinetic theory of matter. So that's the first topic that we are going to do under chemistry. Now, kinetic theory. Okay, when we talk about kinetic theory, we are simply talking about motion. Okay, motion. We're talking about something moving. Okay, we're talking about something moving. So kinetic theory of matter. So we're talking about motion in matter. Okay, motion in matter. Okay, motion in matter. So for us to understand this motion in matter, we have to know first what is matter. Okay, what is matter? So matter is simply anything that occupies space and has weight, or anything that occupies space. Okay, anything that occupies space and has mass. Okay, anything that occupies space, okay, and has mass. Okay, that is what matter is. Anything that occupies space and has mass. Okay, so the space we're talking about here, in other words, we call it volume. Okay, the space we're talking about here, we call it volume. And then the mass here we're talking about is the same mass we know, in kg. Okay, so anything that has these two things, it has volume and mass, it is what? It is matter. Okay, anything that has these two, volume and mass, we classify that as what? As matter. Okay, so now another important thing to know about matter is that matter exists in three forms, or what we call states. Matter exists in three forms, what we call what? States. Okay, it exists in three forms that we call what? States. Okay, three forms that we call states. So number one, matter can exist as a solid. Number two, it can exist as a liquid. Number three, matter can exist as a gas. Okay, matter can exist as a gas. Okay, so now we've known something about matter. Let's go back to kinetic theory. Okay, kinetic theory. So kinetic theory of matter. Okay, so it states that all matter, okay, that is solid, liquid and gas, all matter is made of particles. All matter is made of what? Particles. Okay, which are in constant random motion. All matter is made up of particles which are in constant random motion. So this, if I ask you, can you state the kinetic theory of matter? This is what I want you to tell me. Or even you find an ECZ question asking you to state the kinetic theory of matter. This is what you should write. All matter is made up of particles which are in constant. So the keywords here is that all matter, we need to look at the keywords. It's made up of what? Particles. So meaning solids, it has particles. Solids have particles. Liquids have particles. Gases also have particles. And these particles, they're in a constant. Constant meaning they don't stop. They're in a constant random motion. They're ever moving. Okay? So that we simply mean they're ever moving. Okay? They are ever what? They are ever moving. Okay? They are ever moving. So let me show you something so that you can have a better understanding. Okay? We're just laying down the basics of chemistry. Okay? Lay down the basics of chemistry. So these boxes that I'm drawing, they represent, so the first one to represent solid, then this one will represent liquid, this one will represent gas. Okay, solid, liquid and gas. So now in gas, so the particles, they are arranged like this. Okay, now these particles, I'm just drawing them big, but they're not this big in real life. You can only see them using machines such as the microscope. Okay, so these are the particles. That's how they are arranged. Since we said all matter is made up of particles, so these are the particles. These are the particles in a solid. Okay, the particles in a solid. So the way they are arranged like this here, they do not leave any space. Okay, the particles, we say they are tightly, okay, they are tightly packed. Okay, particles are tightly packed in an orderly manner. Particles are tightly packed. Okay, particles are tightly packed. Now if these particles are tightly packed and we said they have to be moving, they are ever moving, so since there is no enough space for them to move, okay, meaning the movement, okay, the movement of particles, okay, the movement of particles in a solid, can say they vibrate. Okay, particles in a solid simply do what? They vibrate. They vibrate about their fixed position, because there's no space here for them to move. Okay, there's literally no space for them to move. Okay, so if you look at this, so the shape of all solids, that's one thing to look at also, the shape of all solids. Because of the particles being tightly packed, solids have a fixed shape. Solids have got a fixed shape. In the volume, it is also fixed. the volume is fixed. So fixed shape as well as fixed what? Fixed volume. Okay, let's look at what is going on in a liquid. So in a liquid, the particles, they're like this. Okay, so you find that there are some few spaces left. Okay, there are few spaces left. All these are spaces, and these particles can move. Okay, so here they are not tightly packed, but we can say they are packed. They are packed closely. Okay, they are packed closely with few spaces. They are packed closely with few spaces. Okay, this means that if we were to look at the movement, okay, the movement here, they slide. Okay, they can move over short distances. Move over short distance. This one can move from there maybe to there. Okay, they slide against each other. Okay, so when you talk about the shape, they don't have no fixed shape. So imagine water is a liquid. Water doesn't have any fixed shape. Right? It doesn't have any fixed shape. Water will take up the shape of anything that you are using. If it's a cup, it will take up the shape of a cup. If it's a container, it will take up the shape of a container. Okay, so volume, again, no fixed volume. Sorry, the volume is fixed. Okay, let's look at a gas. Now, in a gas, it's a bit interesting here. In gas, we have the particles. They are very far apart from each other. Okay, the particles are far apart from. So particles are spaced far apart. Okay, particles are spaced far apart. Okay, so movement, they move freely at high speed even. Okay, no fixed shape. Again, no fixed volume. Okay, no fixed shape, no fixed volume. Okay, so this is what the kinetic theory of matter actually does. What state time. This is how the kinetic theory of matter states. So you can see. So what you should know here is how all this is happening. The particles, you must know the movement. Okay, know the movement in solids. First, know how the arrangement of particles. The arrangement. So this is called the arrangement of particles. Here they are tightly packed. Here they are closely packed with few spaces. Here they are spaced far apart. Okay, they are spaced far apart. So here, because they are tightly packed, the particles do not move. They simply do what? Vibrate. But here, because they are distances, short distances, there are few spaces, so they can move over those few spaces. Then the shape, here it's fixed shape, fixed volume. That's fixed shape. I mean, no fixed shape. Okay, no fixed shape, but fixed volume. Okay. Then for the gases, no fixed shape, no fixed volume. Okay. So now let's look at something interesting. Okay, we're still under chemistry. We're still under matter. Okay. So this is very important. Please pay close attention on this one. So like I said, as I'm teaching, I'll be telling you where to focus more okay, where to pay close attention. So changes, okay, changes of state. This comes, please, I'm begging you, pay attention here. So changes of state. Okay, so we said matter has got three states. Matter has got three states. Okay, three states. Matter has got three states, and we said these states are solid, liquid, and gas. Okay, these are the three states. Okay, the three states. So now, changes of state, we are simply saying that a solid can change to a liquid, and the liquid can change to a gas can change to a solid, and the gas can change to a liquid. Then, so this is what we are simply trying to do to say. So I'm going to illustrate this using a triangle. Okay, here we are going to have solid. Okay, then here we're going to have liquid. Then here we're going to have what? Gas. So this triangle should be in your head. Okay, you should know. Okay, so from solid, so when a solid changes to liquid, okay, there the process here. Okay, so solid going to a liquid like this. Okay, this solid meaning you're melting it. For example, if it is wax, okay, for those of us who have seen wax, when you heat this wax, it will melt. Okay, it will melt into liquid. Melt into liquid. So solid goes to liquid. So the process here is called melting. Melting. Okay, melting. So it's called melting. Then vice versa. If now you take a liquid to a solid, for example, you put water in a fridge. You find that it has become ice. Okay, another example of a solid is ice. So here it was water, you put it in a fridge, it becomes ice. So this process is called freezing. It is called what? Freezing. Okay, it is called freezing. So if I ask you what is melting, the change of solid to liquid. Okay, what is freezing? The change of liquid to solid. Okay, then liquid to gas. Okay, liquid to gas. Okay, let's start. Liquid to gas. So liquid to gas, I'm going to give you an example. Let's say this water, you boil it on a stove. Okay, you boil the water on a stove. Right? Once you boil the water on a stove, it will boil and then it starts changing to gas. Okay, so you can't see it with your eyes. It changes to gas. Okay, changes to gas, or what we call water vapor. Okay, so the best gas we can give an example here is water vapor. So the process is called boiling. Okay, boiling. There's another process again. There are two processes here where a liquid changes to a gas. For example, when you are not boiling, you're not using a stove, but you find that when you wash your clothes, you hang them. Okay, if you put a shirt here on a hanger, okay, so this is a shirt. Okay, this is your shirt. You put it here on a hanger. Okay, and it's sunny on a sunny day. How does this shirt become dry? All the water that was inside this shirt, okay, evaporates. So the other process is called evaporation. Okay, so liquid changing to gas, it can be boiling or evaporation. Boiling is where you are heating, but evaporation happens on its own. It happens on its own. It's a slow process compared to boiling. Okay, so you must know the difference between boiling and evaporation. Okay, they both change liquid to gas, but we must know the difference between the two. Okay, the difference between the two. Then we have this now, where solid is changing to a gas. So direct change from solid to gas here in chemistry. Okay, the direct change, let me write it nice like this. It is called the sublimation. Okay, it's called the sublimation. We call it what? Sublimation. Okay, sublimation. Similarly, when you take it back like this, it's also called the sublimation. It's a direct change from solid to what? To gas. Direct change from solid to gas. Okay, so know this diagram. Okay, very important. Okay, this is very, very important. Okay, I've put a star here. Very important. Then let's look at now certain important curve also. Very, very important. Okay, very important. Okay, very important. So we call this a heating curve. Okay, look at what we call a heating curve. Okay, a heating what? A heating curve. So a heating curve here. So any curve, you're going to have the y-axis as well as the x-axis. Okay, the y-axis as well as the x-axis. Okay, so you have this side, it is time, and this time is being measured in seconds. Remember the SI unit for time are seconds. Then here, this side, you have temperature. Okay, temperature, the SI unit for temperature, it's actually the SI units for temperature, it's actually Kelvin, but here we use degrees Celsius. We're using degrees Celsius. Okay, so let's say what we want to heat here. What we are trying to heat here, let's say it's ice. Okay, now ice, what is ice? Ice is just water that has been freezed, and hence it's in solid state. Okay, a heating curve for what? For ice. So when you get the ice, okay, then you start heating. Okay, so the first state that it will start in here, the ice will start as a solid. Okay, it will start as a solid. Okay, so as you are increasing the temperature here, it will reach a certain level where it goes flat. This is an important state for you to know. Then after it becomes flat, you find that it's no longer solid, it becomes liquid. So here it was ice. Here it's now liquid, which is what? Water. Okay, so again, as you increase, at a certain point it becomes flat again, then it changes the state again. Now it's gas, what we call water vapor. Okay, water vapor. So now this is what we call a heating curve, right? A heating curve. Okay, a heating curve. Okay, so when you heat here, you've applied heat. This solid, it has to do what? What is the change of state from solid? to liquid. What do we call that? From solid to liquid. Remember, don't forget whatever you learn in chemistry, don't forget. Okay? From solid to liquid, it's melting. So that is what has happened here. Okay? The solid has melted. So at this point now, this point where it remains flat here, this point, okay, it is called, this point is called the melting point. Okay, we call it here, we'll just write MP, melting point. So this is the melting point. The point, what is melting point? Okay, what is melting point? Melting point is a point, okay, point at which a solid changes to liquid. A point at which a solid changes to liquid. So at this point here, this solid is changing to a liquid. So meaning here, it's going to exist. You are going to have part of it will be solid, part of it will be liquid. Okay? Because this solid is changing to liquid at this point. But once it stays here, going up now, it's completely liquid alone. Okay? So at here, it's solid alone. It reaches melting point. This solid now is being changed to liquid. So you have solid and liquid existing together. Okay? So at this point here again, the other important thing to know, when the curve is flat, you must know that here, when the curve is flat, okay, when the curve is flat, we should know that here, the temperature is constant. Okay, temperature here is constant. So two things to know, please don't forget this. When it's flat, the temperature is constant. It's the melting point. Okay, there is solid and liquid. So here, this is an important part you should know here. Wherever you have like a flat line, number one thing to know is that the temperature remains constant. Why is the temperature constant? Because it's now changing from solid to liquid. Okay, the temperature is constant. Okay, so now it's a liquid. Okay, it is a liquid. Here again, it remains flat. Because what is happening? You have liquid changing to gas. This liquid is changing to gas. Okay, this liquid is changing to gas. Now, where a liquid changes to gas, what is that called? Okay, it is boiling. Okay, it is boiling. Okay, liquid changing to gas, boiling has to take place. So this point here, we call it boiling point. Okay, we call this point boiling point. Okay, or we can write it here as BP. Okay, it is the boiling point, which is BP. Okay, BP, boiling point. Okay, again here, know that temperature, okay, temperature is constant. Okay, the temperature is constant. So everything now is changed to gas. Okay, and hence the cooling curve is complete. Okay, the cooling curve is complete. So you should know this. What you should know here, know the melting point. So the boiling point, how can you define boiling point? Very easy. Boiling point, you define it as a point at which liquid changes to gas. Point at which liquid changes to what? To gas. Okay, a point at which liquid changes to gas. So all those flat lines, we call them changes of state. So this is a change of state. This is a change of state. These two, very important. The first one is melting point. This other one is boiling point. Okay, that's what I wanted to know. Okay, I wanted you to know this. Okay, in this video. Okay, so this is called a heating curve. This is called a heating curve. Okay, so before we end the video, let's look at another curve. Okay, another curve. Okay, look at another curve. This curve, it's just the opposite of a heating curve. Okay, and this curve we call it a cooling curve. Okay, so again, under a cooling curve, you have this. Okay, so for a cooling curve, so you have temperature here in degrees Celsius, and you have time here in seconds. Okay, but for a cooling curve, it's just the opposite. So it starts like this, then it goes like this, it's like this, goes like this, and then it comes down like that. Okay, so meaning it starts as a gas. Okay, then here it is what? Liquid. In here it is what? Solid. Okay, it is solid. Okay, call this a cooling curve. So at this point here we've got gas, liquid. Here we've got liquid, solid, just like we talked about on a cooling curve. Right? So again here this is a change of state. Okay, it's a change of state. Okay, so here this is a change of state. Okay, this is BP, so BP and MP. Okay, so that's just the opposite. This is called a cooling curve. So when you start it at the bottom here, it's called a cooling curve. Right? Okay, so here heat is being lost. You can see here temperature is decreasing. Okay, so when you cool this, it's more like you've put what can I say, you have this gas sign, then you begin to cool it, begin to cool the gas. It is going to change to liquid. You cool it even further, becomes solid eventually. Okay, becomes a solid eventually. Okay, so that's what we are supposed to know in this video. Okay, so now the rest we will learn in a live online class at 20 hours for those who are under my tuitions.